Hi guys, this is Notes 7.6 for Newton's first and second laws on forces. All right, so let's see. I'm gonna skip that. All right, so what you guys should be doing is filling out the notes either on Kami, there's a link to Kami through the modules, or you can print out the notes through the Word document that I posted and fill in the blanks as we go so you have something that you can look at while you're doing the assignment. Okay, so Newton's first law states, an object at rest remains at rest, and an object in motion maintains its velocity unless it experiences an unbalanced force. I'm sure you guys have heard something along these lines of an object at rest stays at rest and an object in motion stays in motion. Okay, so this just means that it's going to stay at its continued velocity unless it experiences some type of force, whether brakes on a car or wind resistance or gravity or something else that will unbalance the force that's being applied. This is also referred to as the law of inertia. Okay, so inertia can be resisted. And so we have nice devices in our car to resist inertia. So in case of a car accident, for example, we have seat belts and we have airbags that will resist this inertia to help protect our bodies and keep us safe in the event of a crash, to prevent our heads from smashing against the windshield or whatever else. So we sometimes want to resist this inertia, and these devices do that. Okay, so for number 3 in your notes, the more mass an object contains, the more inertia that is present. Okay, so mass is essentially how much stuff is shoved inside the volume. Okay, it relates to weight, but it's a little bit different. So let's see if you guys can figure out which is going to have more inertia. And let me pull up my pen here. Okay, so more inertia because it has more mass, right? So which of these things has more mass? A cell phone or a telephone? Now, I wonder if any of you have actually ever seen a telephone that is not a cell phone. Hopefully you have, and you would know that a telephone would have more mass and therefore more inertia. Desk versus chair, I'm sure you guys know. Desk, more inertia because more mass. Although I guess it really depends on the desk and the chair we're talking about. But let's talk about the school desk and chair. Textbook versus wallet. I hope you guys know textbook. Pen versus stapler. Probably going to be a stapler if it's a standard stapler. Sports car versus a big rig. Big rig is one of those real big trucks. And then bear versus a rabbit. Hopefully you would say bear. Didn't. There. Okay. So that was Newton's first law. Object in motion stays in motion, blah, blah, blah. Okay, Newton's second law states that an unbalanced force acting on an object is equal to the object's mass times acceleration. So this is a very simple math problem, mass times acceleration. Okay, so we write this as force equals mass times acceleration, or you're going to see F equals ma. Okay, force equals mass times acceleration. So it's written like this. If you see F equals ma, we're talking about Newton's second law. Okay, so you need to make sure you remember that. All right, so when we're talking about the force, we're going to need units. And the units we're going to use is newtons. And we derive newtons. So 1 Newton equals 1 kilogram times 1 meters per second squared, which is mass times an acceleration, because meters per second squared is our acceleration unit. Okay, so when you have a kilogram times meters per second squared, you're just going to say, okay, that unit is newtons. All right, to make it easy. So here's our first example. We have zookeepers, and they're trying to lift a stretcher that's going to hold a sedated lion. So the lion's asleep, thankfully. The total mass of the lion and the stretcher is 175 kilograms. Now, the upwards acceleration of the lion and the stretcher, so they're lifting upwards, is this acceleration right here, meters per second squared. So then we're going to solve what is the unbalanced force necessary to produce this acceleration of the lion and the stretcher. Well, this is very simple. We have mass, we have our acceleration with our units, and we have force equals mass times acceleration. So our answer is 115 newtons, and the unit is newtons because we have kilograms times meters per second squared, which is equal to newtons. Okay, so here's our answer for that one. So in calculating force, because I'm probably not going to give you F equals ma, but I might give you this. It could also be in a circle, okay? So you might also see it in a circle. It means the exact same thing, okay? So in the way that we've used the triangle before, I know that the relationship between force and mass, we divide, okay? So acceleration equals force divided by mass. So we have these. So acceleration equals force divided by mass. And force equals mass times acceleration because they are next to each other. Okay, when they're next to each other, it's multiplication. When they're one over the other, it's division. One over the other, it's division. So the only time it's multiplication is when you're solving for force. Okay. All right. So let's try this practice problem. What is the net force necessary? So we have a mass, right? Here's our mass in kilograms. And then we have an acceleration here. So really, the rest of the wording is not necessary. If it says, what is the force? And you have a mass and you have an acceleration, you're going to use force equals mass times acceleration. So we have our mass, which is 1,600 kilograms, times our acceleration, which is 2 meters per second squared. And when you do 1,600 times 2, you get 3,200, and the unit is newtons because kilogram times meters per second squared is newtons. Let's try another one. A baseball accelerates. Okay, so this is our acceleration right here. If the force acting on the baseball is 1.4 newtons, what is the baseball's mass? Okay, so now we are going to, let's refer to our triangle. If you can remember that F is at the top, then I know it's M and A, okay? So now we are trying to solve for the mass right here. They gave me the acceleration of 9.8. It says accelerates 9.8, and it's telling me that the force is 1.4. So that's that guy. So mass equals force divided by acceleration because you have force over A. All right. So my force is this 1.4 newtons. So let me write that. 1.4 newtons divided by the acceleration, which is 9.8 meters per second squared. Okay. And because it's asking for mass, okay, I know that it's going to be in kilograms because we have newtons and meters per second squared. So the only thing left is kilograms. So once you divide, you should get 0.14 or approximately kilograms. All right, let's try another one and let me see if I can erase this. Okay, so now we're solving for acceleration. We need A, and acceleration is force over mass. So I'm running out of room here. Acceleration equals force divided by mass, okay? So we're solving for acceleration. It says 58 kilograms. That's my mass. Kilograms is a mass. And here's my force. It says force right here. So we have 15 newtons divided by 58 kilograms. Whoops, ran out of room there. Kilograms. So 15 divided by 58, and you should get 0.26. And because I know we have newtons and kilograms, then the leftover is meters per second squared. You need to know what units we're dealing with here. All right, let's try a couple more. A sailboat and its crew have a combined mass. So here's my mass. It's telling me. Ignoring friction, so you don't have to worry about friction. If the sailboat experiences like we talked about wind resistance previously. If the sailboat experiences a force, so here's our force, pushing it forward, what's the sailboat acceleration? All right, well, acceleration equals force divided by mass. Okay, if we use that little triangle, we have force, we have acceleration and mass. Okay, so acceleration is force over mass. So here's our mass and here's our force. So acceleration equals 895 newtons divided by our mass of 655 kilograms. So once you divide that, and I know I have newtons and kilograms, so what's left over is the unit of meters per seconds squared, and you should get this answer here, which eraser. Okay. All right, let's try one more. I think it's one more. What force is necessary to accelerate? Okay. Accelerate a 1,250 kilogram car at a rate of 40 meters per second squared. Okay. Now it's a little confusing because I'm using the word rate, but you can ignore that word rate and look at meters per second squared. What is that? That's an acceleration. Okay, so I'm trying to solve for force, and I know that from our triangle, force is acceleration times mass. So force is acceleration times mass. So I'm solving for force. So you can forget words, just look at the units. What are they telling me? So force, so my acceleration is this, 40 meters per second squared, times, here's my mass, 1250 kilograms. Okay, and so I've got meters per second squared, I got kilograms, I know that that's going to be a unit of newtons, and that should be my answer, 50,000 newtons. Last one, solving for mass, so it's going to be mass equals force over acceleration. Here's my force, 34 newtons, divided by an acceleration of 4 meters per second squared. So newtons and meters per second squared, I know my unit is going to be kilograms. You divide and you should get 8.5 kilograms. All right, so let me know if you guys have any questions. There is an optional practice, and there's an answer key posted. Again, I have some optional office hours if you guys have questions, or feel free to shoot me any emails. Okay, thanks. Bye.